Okay, so we want to evaluate using the properties of logarithms, except really what we have is an exponential um, ex expression, but um, I'm going to write it this way, and let's set that equal to some kind of variable. Whatever you choose is going to be fine. I'm going to use let's use an m, and again we are going to use the properties of logarithms, but because it's written in exponential form, let me write it in logarithmic form. Now, it looks like it's in logarithmic form because there's a logarithm in here, but it's basically, as I've noted in the past, that's the base. This is the exponent, this whole thing here. And I like to call this in this case, it's the answer, but it's going to become the argument inside the logarithm. And so what I'm trying to allude to is that we're going to write this as log base E, and then our argument goes here. And in a logarithm, the exponent goes on this side. So it may be helpful to, draw arrows to remind you of where things are supposed to go when you're going from exponential form to logarithmic form and so on, right? And then I want to make a substitution here because we had said before that log base E is the same as that symbol, ln, which stands for the natural log. So I'm going to replace the log base E with ln of m equals natural log of 4. It's not in parentheses here, but it's the same thing. And so I'm looking at all the properties to see if there's one that's specific here. And I don't think it's one of those, but I think it's pretty obvious that m is equal to 4. So it turns out that none of those rules are the ones that we're applying. But this is the one that we want. It's called the equality rule. And it tells us that as long as you have the same base, then the things that are inside are equal to each other. That's why m equals 4.